Administering DNS. So far in our videos on DNS, we've seen how to install a DNS server and configure our zones. So in this video, we'll take a close look at what options we have when we administer our DNS server. So we'll start by taking a look at the properties of our DNS server. So we'll right click on our server here, DC01, and we'll choose Properties. Alright, well this defaults here to the Interfaces tab, so we'll start here, and on this tab we can set which network interfaces we want DNS to listen for DNS queries. Now the default here is for all IP addresses. Now in my case, I only have one single network card, but if you are running multiple network cards in your server, you could leave the default and it will listen on all network cards, or you can select a specific card from the list. Now if you do want to select a specific interface only, we'll click on the Only the Following IP Addresses radio button, and then we'll simply check the box next to the IP addresses that we want to use. Now on the next tab, the Forwarders tab, we can set additional DNS servers to which this DNS server will forward queries that it can't resolve locally. So all we need to do is come down here and click on the Edit button and then enter in the IP addresses of any servers that we want to forward queries to. However, I'm not going to go any further into this right now, as we will have a separate video on forwarders later in this DNS series. Now in the next tab, the Advanced tab, we can set options that will affect the advanced configuration of our DNS server. Now at the top up here we can see the version of our DNS server, which is currently running 6.0.6001. And below this, in our server options window, we've got several really important options. Now in most cases, you're probably going to leave the defaults as they are, but we'll go through them now and we'll talk about what they do, and you can make up your own mind whether you want to enable or disable any of these features. Now at the top here we can disable recursion, which as it says also disables forwarding. Now by default, recursion is enabled for the DNS server service. Now if recursion is disabled, the DNS server service will always use the referral or iterative method regardless of the client request. Now Windows 2008 DNS servers can, and by default do, use recursion to query other servers on behalf of the requesting client in its attempt to fully resolve the name, and it will contact all of the DNS servers it can in turn to find out the answer. And if you check out our video on DNS resolution, we'll talk about recursion in great detail. Now in contrast though, the root servers use an iterative response, which basically says, I don't have the answer for you, but I do know someone that might be able to tell you the answer, so you should go and ask that server for the answer, as I'm not going to do it for you. So recursive lookups continue until our server here receives an authoritative answer for the name that it's querying for. So our server then forwards this answer in a response to the original query from the requesting client. So generally, you would only disable recursion if you want the DNS server to only manage internal names, or the server is unable to resolve external names. Now, in these cases, clients would then be expected to try another DNS server to resolve their names. Now the next option we have here, Bind Secondaries, which is enabled by default on Windows 2003 servers and it's disabled here in Windows 2008. This adds support for the fast transfer format during zone transfers. Now, if you're using Windows-only DNS servers, checking this box really has no effect, as it won't affect zone replication between DNS servers. The only reason you'd want to have this box checked is if you're transferring zones to bind secondary DNS servers that are running 4.9.4 or later, and they support the fast zone transfer format. Now you can also set this from the command prompt using the DNS command. So if we go and click on Start, and we'll open up a command prompt, and we'll type in DNS command, or DNS CMD, followed by the server name, in which case this will be DC01, /config, and add in the bind secondaries switch, and then we'll either set this to a 0 or to a 1. Now 1 being enabled and 0 being disabled. Alright, well our next option we have here, fail on load if bad zone data. This determines whether we force the DNS server to parse zone files strictly. Now by default, the DNS server service will log data errors and ignore any errors in zone files and continue to load it anyway. So checking this box will prevent the DNS server from loading a zone that contained errors. Now the default obviously is disabled, and I'd recommend that you leave it that way. Now the next one we have, enable round robin, allows you to set up multiple host records for a given host name and have our DNS server dish out those IP addresses in order. So let's say I have 3 servers that I want to load balance as a single web server. Just by leaving the default setting of round robin enabled and creating a few host records, we could have a poor man's load balance server. So to illustrate how round robin works, what we'll do is we'll cancel this and we'll go to our forward lookup zones and we'll right click and we'll go and create a new host record, and I'm going to give this record a name of www, and we'll simulate running a web server here, and we'll give it an IP address of 10.32.0.90 and we'll click add host. Now we'll keep this window open again and we'll add in another one. We're going to enter in the same name of www and we're going to give this one an IP address of 10.32.0.91 and we'll add that one as well. And we'll add in one more, www, and the IP address of 10.32.0.92. Alright, and we'll add that host in as well. Okay, now if we go and scroll down here, we should see we have 3 www host records all pointing to different IP addresses. So now what we'll do is we'll go and open up a command prompt and we'll type in Nslookup followed by www and we'll hit enter. And you can see we've got back 3 IP addresses, 92, 91 and 90. So we'll rerun a command again. Now notice this time the order has changed. It now starts with 91, 90 and 92. So let's run that command one more time. Now this time 90's moved up to the top. Now we have 92 and then 91. So let's run it again. And now we should be back to where we started at the very top, which was 92, 91 and 90. And if we scroll down to the bottom, we have 92, 91 and 90. So as you've seen, round robin DNS is going to repeat this sequential dishing out of IP addresses continually, which can certainly alleviate a busy server by distributing the load to different servers. Now, the main downfall of using this method is that if one of these servers happens to die, DNS doesn't know anything about it and it's going to continue to dish out that dead IP address. So effectively that means in a situation like this, every third hit on our website is going to fail. So whilst this is a useful method of spreading the load over multiple servers, personally I'd much prefer to use real load balancing or clustering technologies that are also available with Windows 2008. Alright, well let's go back to our DNS console. We'll right click on our server and choose Properties again, and then we'll go to the Advanced tab. Now the next option we have here is to enable Netmask ordering, and this determines whether DNS will use local subnet priority. Now in the situation where you have a multi-home computer, that's a computer with multiple network cards, the one which is determined to be the closest to the DNS server is going to have priority. So for argument's sake, let's assume that I've got 2 network cards in my server here. Now one of them has an IP address of 10.32.0.90 like we added a minute ago, and the other has an IP address of something like 192.168.0.100, which is obviously on a totally different network. Now because our DNS server is on the 10.32 network, the 10.32.0.90 network interface is going to be given local priority. So we can illustrate this by deleting one of the hosts that we created a moment ago. So let's go down here and we'll delete the bottom one, .92, and we'll change 91 to a different IP address. So let's change 10.32.0.91 to 192.168.0.100, and we'll click on OK. Now we'll need to go back into the properties of our server and on the Advanced tab, and we'll uncheck Enable Round Robin, as it tends to get in the way and sometimes prevents Netmask ordering from working properly. So we'll click Apply here, and now we'll go to our command prompt and we'll do an Nslookup, and we can see here that the first IP address that comes back is our 10.32.0.90, and obviously our 192.168 address comes second, so we'll run Nslookup again and notice that it's continually the same. Now the reason in this case that 10.32.0.90 is always being returned first is because our DNS server is on the same subnet and it prioritizes the local host as being the first host returned in a query. So this will make accessing the server faster, since it's always going to attempt to return the local host first. Alright, well, back in our DNS console, the last option we have here is to secure our cache against pollution. Now, leaving this option to its default setting of enabled will let the DNS server attempt to clean up DNS responses to avoid cache pollution. This setting eliminates adding unrelated resource records that are included in a referral answer to our DNS cache. So if our DNS server here discovers that referred names are insecure or potentially bogus, with this setting enabled, it's just going to throw them away. The DNS server will check the response that's given in a referral to see if it came from the same DNS domain name for which the request was for. So for example, if our DNS server sends out a request for the web server at Microsoft.com and the response comes back as something outside that domain name tree, such as the web server from Dell.com, then the DNS server won't cache the response. Now you can see here our DNS server by default will use multi-byte Unicode 8-bit translation encoding scheme, although you can change this to an ANSI scheme if you like. Now when our DNS server starts up, it will by default load the zone data from both Active Directory and the registry, as Active Directory integrated zones use information stored in Active Directory and the registry to initialize and load any data for use on our server. But if you like, you can change this so our DNS server boots up from a file or just the registry. Non-Active Directory DNS servers will initialize from the registry information, but if you do decide to use the file method here, the file must be a text file named boot located in your DNS server in your Windows System 32 DNS folder. Now down the bottom here we can also enable the cleanup of records that are older than 7 days, which is the default. And down here, if we totally muck up everything on this tab, we can reset everything back to the default settings. Alright, well our next tab up here is the root hints tab, which is where we can set the IP addresses of the root DNS servers, and this is populated automatically for us when we first install DNS on our Windows 2008 server. And it's not really recommended that you change these, but if for some reason your copy is modified or corrupted, you can certainly edit these if you like. So in the middle here we can see our root servers listed from A through to M, and if you do want to edit any of these, you can simply highlight an entry and then click on the edit button, and from this window you can change the record's details if you need to. Now our next tab, the security tab, simply provides us with the standard Windows access control list where we can assign permissions to users or groups to determine if they're able to create or modify or delete any objects in our DNS server. Now by default though, only members of the administrators, domain admins, enterprise admins and DNS admin groups can make changes to our DNS server. Now on the monitoring tab, we can perform some basic tests against our DNS server. We could choose from a simple query and a recursive query, or we can perform both. So to run a test, we'll simply check the box next to the test that we want to run, so we can run both if we like, and then click on Test Now. Now when you run one of these tests, down the bottom here you'll see the results of the test, and hopefully if your DNS server is functioning correctly, you're going to see both the simple and recursive queries come back with a pass. Now we can also schedule automatic testing at certain intervals if we like, and the default here is to test each minute, but in all honesty, unless you think you have problems, you probably won't need to enable this option. Now our next tab here is the event logging tab, and this is where we can tell our DNS server to write all records to the event log when any errors or any warnings occur. Now the default is to write all events, but you can choose to write none of them, just errors only or errors and warnings. Now I'd recommend that you do leave the default here to log all events, because when you're troubleshooting an important service like DNS, I personally prefer to have as much information on hand to assist me, so for me I'll leave it as it is and we'll log all events. Now the next tab, the Debug Logging tab, is where we can tell our DNS server to log to a text file packets sent to and from the DNS server. Now a word of advice though, debug logging on your DNS server is going to slow its performance considerably, so only use it for troubleshooting and turn it off during normal use. Now by default it is disabled, but we can enable it by clicking on this box here to log packets for debugging, and down here we can see a bunch of pairs of options here that we can choose to log, But just be aware that you have to choose at least one of them for each of the categories. So you can try to remove both of them if you like, but at least one of them must be selected. Okay, so with debug logging enabled, we can log packets that are traveling outbound from our DNS server or inbound to our DNS server. We can also log based on whether the packet's a UDP or a TCP packet. Now for the most part, DNS uses UDP, so you probably would enable this one if specifying protocols. TCP is used for zone transfers and really large responses, so depending on what you're trying to troubleshoot, you could use that as a guideline. Now we can also filter on the contents of our packets, whether we're looking to log standard queries and transfers, dynamic updates, or notifications to other DNS servers that our zone has changed. Now similar to our packet direction, we can also log packet types, whether it's a request for something or a response to a request. Now we can also log the details and filter out packets by specific IP addresses if it's a certain host that we're trying to debug. Now under our log file box here, you can specify a path and a file name for the debug log file. And if you just enter in a file name here and you don't enter in a full path to the file, your file is going to be saved in your system32/DNS directory. And finally down the bottom here, we can set a maximum size that we want to allow our log file to grow. Now if this maximum size happens to be reached, then the file is going to be overwritten, starting with the oldest records first. Alright, well that's all of the tabs when we right click in our server in our DNS console. So if we cancel this and we'll go and right click on our server again, you can see here that we do have a few other options that we haven't yet discussed. Now our first option here to configure a DNS server simply starts up the configure a DNS server wizard, which we can use to configure forward and reverse lookup zones, route hints and forwarders. But you'll probably find that in most cases, since you'll have installed DNS when you installed Active Directory, that all of these things, with the exception of reverse lookup zones, are already created for you, so you probably won't need to run this at all. That said, it is here if you want to blow your configuration away and then start again. Now next we can create default application directory partitions. Now an application directory partition is a directory partition that's replicated only to specific domain controllers. A domain controller that participates in the replication of a particular application directory partition hosts a replica of that partition. Now only domain controllers that are running Windows Server 2003 or 2008 can host a replica of an application directory partition. Now one of the benefits of an application directory partition is that for redundancy, availability or fault tolerance, the data in it can be replicated to a different domain controller in a forest. Now the data can be replicated to a specific domain controller or any set of domain controllers anywhere in the forest. Now this differs from a domain directory partition in which data is replicated to all domain controllers in that domain. Storing this application data in an application directory partition instead of a domain directory partition may reduce replication traffic because the application data is only replicated to specific domain controllers. Now if we choose this option, we'll be asked if we'd like to create a single partition that stores our DNS zone data, and that'll be replicated to all of our other DNS servers in this domain. Now at this point, if I do select yes, I will get an error because this partition will already exist. Alright, well our next option up here is to create a new zone, and that's going to start up the new zone wizard, which will allow us to create a forward or reverse lookup zone. And this is essentially the same as right clicking on our forward or reverse lookup zones down here and then choosing a new zone. Now we can also set the aging and scavenging properties for all DNS records, and we saw how to do that earlier. We can also choose to scavenge all of the records in our DNS server now by selecting this option. We can update our server data files. We can clear the cache, and this does, as the name implies, and it clears our DNS server cache. But if we go to our command prompt here, we can also do this by using our DNS command. So we'll type in DNSCMD, followed by our server name, which is DC01, and then adding in the clear cache switch, and then hit enter. Now finally, our other options here are to launch a command prompt, and this will start directly into our Nslookup utility if we happen to be too lazy to type it in manually. And on our all task flyout menu, you can see we have much the same options, but we can also stop, pause, start, and resume our server. Alright, well, we've now covered all of the DNS server options, so let's take a look at the properties of our individual zones. So we're going to right click on our forward lookup zone of winstructorlab.com, and at the bottom we'll choose Properties. Now on the first tab here, the General tab, we can see the status of our DNS server is running, which is rather important of course, but we can also pause it here if we like. Now the type of server that we're running is currently a primary Active Directory integrated zone. If we click on the Change button, we're able to change it from its current configuration of a primary zone to one of these other choices that we've already talked about in our DNS zones video. Now we can also see that this zone is going to be replicated to all DNS servers in this domain, and if we click on the Change button, we could choose one of these other options if we like to replicate to all DNS servers in our forest, or to all domain controllers in this domain if we happen to be running Windows 2000 DNS servers as well. And at the bottom here we have the Dynamic Updates drop-down box, which is currently set to Secure Only. Now this option is only available with an Active Directory integrated DNS server. Now we can change this to None or Non-Secure and Secure Updates, but we'll go ahead and leave it as it is for security purposes to Secure Only, since Secure Updates Only allow clients that are already a member of the domain to update their DNS records, and that can prevent bogus clients from registering themselves with DNS. Now finally at the bottom here we have the Aging button. If we click this button, we can set how long our DNS clients must wait before attempting to refresh their host records with our DNS server. Now Windows hosts will attempt to register themselves with a DNS server every 24 hours or when they reboot, so selecting this option here prevents them from doing that, and it'll cut down a fair bit of network traffic as well, especially in a large environment. And down the bottom here, after this amount of time expires, then the client will refresh itself in DNS. So in 7 days, hosts will then re-register with our DNS server, and if records aren't refreshed, you can check this box at the top to scavenge or remove stale DNS records from our DNS server. Now, checking this option is a good idea because DNS will remove host records that appear to be no longer in use, or maybe a user's on holiday or something, or hasn't logged in for a while. So this option is recommended from keeping your DNS server from growing unnecessarily in size. Now our next tab is the Wins tab here, and here we can use a Wins forward lookup. And if DNS can't resolve a host name because it doesn't have a host record in the authoritative zone, it'll then query the Wins server. So let's say that we're trying to resolve a computer named server01.winstructorlab.com. So if our DNS server can't contact server01.winstructorlab.com, it'll strip off the winstructorlab.com portion of the name and send the Wins server a NetBIOS name request just using the host, in this case server01. So if server01 is registered in Wins, the Wins server will return the record to DNS, and DNS will then create an A record in its zone and then forward the IP address of server01 to the client that requested it. Now if you do have non-Windows 2000, 2003 or 2008 DNS servers such as Bind, you might want to check the next box to not replicate that record. And that's because DNS servers other than Windows ones don't handle Wins records very well, and you might have zone transfer problems. Now the Advanced button down here allows us to cache a host name that it resolves, and it'll keep these records by default for 15 minutes. Now in our Lookup Timeout field, this just says that if it doesn't get a response for the first Wins server in 2 seconds, which is the default, it's going to move on to the next one in the list, and so on until it either receives a response or it exhausts all of the Wins servers in the list, in which case you're just going to receive an error message. Now in our next tab, the Zone Transfers tab, this is where we can configure other DNS servers, for example our secondary DNS servers, to receive a copy of this zone. Now by default, zone transfers are disabled, and that's a good thing, and it locks down our DNS servers from allowing rogue servers to request a copy of our zone. But when you do want to allow zone transfers to other servers, you don't want to use the first option here to any server. you'll only want to allow zone transfers to servers that you've either listed on the Name Servers tab or specific ones that you can add to this list right here. So if you do want to add in specific servers, we can choose the bottom radio button here only to the following servers. We'll click on the Edit button and then enter in the IP addresses or the names of the DNS servers here and then click on OK. Now, primary DNS servers will contact the secondary DNS servers to inform them that there have been updates to their zone, such as a new host record's been added. And if we click on the Notify button here down the bottom, we can set our DNS server to contact the secondaries and tell them when an update has occurred. So we could choose to automatically notify the following servers from this list, or again, servers that are listed on our Name Server tab. Now the next tab, the Security tab, provides us with our standard Windows access control list where we can assign permissions to users or groups and grant them permissions to be able to create, modify or delete objects. Now on our Name Servers tab, we can specify the name servers that are authoritative for this zone. So here we can see we have two servers, dco1.winstructorlab.com and dco2.winstructorlab.com. Now if we wanted to add in another server, we can simply click on Add and then enter in the fully qualified domain name and IP address of the server and then click on OK and we're done. Now of course if you do have any old servers in here that you want to remove, we can simply highlight the server and click the Remove button, or we could edit any of the existing name servers again by highlighting the server in the list and then clicking on Edit. Now our final tab here is the Start of Authority tab, which is where we can set information about the primary DNS server for our domain. Now the first field here is the serial number, and this is where the secondary DNS servers will compare their serial number against our primary server's serial number, and if this number is higher than theirs, a zone transfer will be performed as the secondary server can then get a current copy of the zone. This number increments automatically as changes are made to this zone, or we can increment it manually if we wish by clicking on this Increment button, and that'll force a zone transfer to be started. Now next we have the name of our primary DNS server, which as expected is our server here, DCO1. Now you can see also right at the end of here that our server name does have this trailing dot after it, indicating the full path back to the root. Now in most situations, we don't ever see or have to enter in this trailing dot when we ping anything or open up a web page, but DNS does use it behind the scenes. Now under the responsible person field, this is actually an email address with the @ symbol simply being replaced by a dot here, so it's valid in DNS. Now the default here is set to hostmaster, but we can of course change it if we like. And again at the right here, to be complete, you can see we have the trailing dot after this email address. Now this refresh interval here defines how long the secondary servers will take before they check back with this DNS server to see if there's been any changes. Now as DNS servers check the serial number, any secondary DNS servers will check the serial number that we mentioned before, and if there have been changes, it'll initiate a zone transfer and then pull those records to the secondary. Now if there have been any problems with performing a zone transfer, it'll then retry after the interval specified here, which defaults to 10 minutes. Now if it's unable to contact this server for a full day, then our secondary is going to expire its copy of the zone after 1 day, and then it won't be used. Now if the secondary is able to then contact this primary server successfully later on, it'll then reactivate its zone and then perform any necessary zone transfers. Now down here we have a minimum time to live, or TTL, and we can see that that's set to 1 hour. This means that when a client successfully resolved a host name using this DNS server, it'll cache the name and the IP address for an hour before it'll expire, and then it will have to query our DNS server again to grab the correct IP address. And for this Start of Authority record itself, we can see here that it's going to be kept for an hour. Okay, well that's our forward lookup zone, so why don't we just now expand our reverse lookup zones, and currently we don't have one, so I'm just going to go and quickly zip through this wizard here and create one. And if we right click on our newly created
Reverse Lookup Zone and choose Properties, and then the Wins-R tab. On this tab, we can specify a Win server to provide further resolution for reverse queries that aren't found inside our zone. But since Wins isn't indexed by IP address, our DNS service can't send a reverse name lookup to Wins to get the name of a computer by sending it an IP address. Because Wins lacks a reverse lookup capability, when DNS receives a reverse lookup request on an IP address, DNS directly sends the IP address in the reverse lookup a node adapter status request. Now the node status response is received back, and let's say that it happens to be for a computer called Server 01. Our DNS server will then add winstructorlab.com, or whatever the domain name we've entered in this box below here is. It'll add that to the hostname of Server 01 and then forward that response back to the requesting client. Now, as with our Wins tab on our forward zone, if you do have non-2000, 2003 or 2008 DNS servers such as Bind, you should check this next box here to not replicate this record, otherwise you might fall victim to the zone transfer problems we mentioned when we discussed the forward lookups earlier. Now the advanced button down here is the same as we saw in our forward lookup zone. It simply allows us to cache names that it resolves, and by default it does keep them for 15 minutes, and we have the same Win server lookup timeout of 2 seconds before we receive an error message. Alright, in this video we've looked at the configuration options we have with a Windows 2008 DNS server, and there's a lot to DNS, but in most cases you'll only need to set it up once properly, and then any maintenance will be minimal. Understanding DNS is crucial to a happy Active Directory environment, so I'd suggest having a play around with DNS on a lab box or two, so set up a couple of boxes and create some zones and primaries and some secondaries and start initiating zone transfers. Then have a look in the event log and see what sort of events you're getting. Turn on logging and take a look at what it tells you. Even install Network Monitor and capture some packets like we've showed in earlier videos. Understanding DNS is a great skill to have, as a good solid DNS installation is going to make other things in your network happy, and in return it makes your life as an administrator much easier. We hope you've enjoyed this video and would like to thank you for supporting Winstructor.